The answer lies in a fundamental concept in physics known as momentum. Imagine you're pushing a toy car and a real car. Both are at rest initially. You give both of them a gentle push. The toy car moves easily, but the real car barely budges. Why is that? This happens because of a property called momentum. Momentum, in the simplest of terms, is the quantity of motion an object has. It's a vector quantity, which means it has both magnitude, how much motion there is, and direction, which way that motion is going. The momentum of an object is calculated by multiplying its mass by its velocity. So a heavier object moving at the same speed as a lighter one will have more momentum. Similarly, a fast-moving object has more momentum than a slow-moving object of the same mass. Momentum is conserved, meaning the total momentum before an event must equal the total momentum after the event, provided no external forces act on it. This principle is often used in physics to solve a variety of problems, from collisions between pool balls to rocket propulsion. Let's summarize the key points about momentum. 1. Momentum is the quantity of motion an object has. It depends on both the mass and velocity of the object. The heavier the object, or the faster it's moving, the greater its momentum. 2. Momentum is a vector quantity. It has both magnitude and direction. When calculating momentum, we need to consider not just how much motion there is, but also which way that motion is going. And 3. Momentum is conserved. The total momentum before an event equals the total momentum after the event, as long as no external forces are involved. Understanding momentum is crucial to understanding how objects move and interact in the world around us. From the cars on the road to the stars in the sky, momentum is an integral part of the physics that governs our universe. So, next time when you're trying to stop a moving truck, or when you see a rocket launch into space, think about the momentum involved. It's not just a concept in a physics textbook, it's a fundamental